good morning, everyone. And I'm really excited to be here today. My name is Irfan Maroof, and I'm part of Microsoft specialist team for advanced data analytics. And today I'm going to talk about observability with Synapse Data Explorer. So I know this community is all about the Synapse and IU data services. So I'm expecting you know like how Data Explorer comes into our offering as a standalone, and within Synapse as a third engine for the observability or the telemetry analytics. And today I'm just going to talk about the two short or the two use cases quickly about where we see the customers are using the Data Explorer, and those use cases are really impactful, and those are not well known. So I just thought, okay, to give some visibility to communities so that they can also leverage the Data Explorer for the similar use cases. So when we talk about the observability, we like everybody talking it like, and we see like a industry, or we even have witness how this monitoring stuff is more and more critical for every type of the application, not just for the data application, but it's also for more microservices, your classical applications. And we have seen like, okay, monitoring, and then APM, and then observability, and now everybody is also talking about the data observability because it's critical for the data intensive application. So, but when we talk in general about the observability analytics, what comes in mind and what makes it difficult, right? You don't know most of the time your business requirement. So one day you have one type of the system, and any like a next day you need to bring a new system, new data product, or something like that. So you should have a comprehensive solution for observability, or something like an engine that can give you capability to do all the things with these changing requirement, right? And you're always looking with this solution something like unpredictable phenomena from your data, from your infra, from your pipeline end to end. And the one thing when we talk about just about the data part of it is like you don't know which schema you are going that you are getting today. Either the same schema is going to you get that tomorrow, or either it's the same application, or you need to onboard a new schema, a new table, or something like that. So this requirement also continuously changing, right? And at the end, when we are observing the more critical platform or a critical application, we need this visibility in near real time, right? You can't just run the query and just wait for, okay, my observability data is going to come in like a next 15 minutes or something. This is not like a acceptable for the business where you have the critical application. So for all these things, like this makes this whole process for the observability slightly difficult. And when we talk about like a more distributed and decentralized application, it adds another level of complexity into the whole observability factor of your application. And next, I just want to bring this like even this talk about how to add observability into a complex event-driven architecture. And we have seen also like a microservices concepts into our like a application side of the organization, or application side of the application side, where we get all the data, where actually the actual business is happening, right? So we have seen this microservices there, and they were evolving also. Like initially they were dependent on the REST API, and then later to bring the more decoupling stuff, they brought also something like everything should communicate through the message broker, or through the event. So that's just like one of the architecture, or sample architecture I picked, and that I have seen the customers are even leveraging similar, but in a real world it's more difficult. But here I just want to show a simple ordering architecture, or an e-commerce system where every microservice is communicating to their topic through a center event hub, or something like a Kafka, and all those topics are just actually take the responsibility of their own microservice, right? And when these messages move from the moment customers start interacting with or initiating the order till to the when it's delivered to the end customers, right? So there are a lot of events that are moving through these channels, and what makes it difficult is like if any of these links is broken, or if any of these this service is not getting the message at the right time, it affects the whole customer experience. So and even for the developer, it makes a lot of their life difficult to identify, okay, where the exact issue is happening. So for that type of actually scenarios, what customers are leveraging, and we have seen a different customer adopted this, they are looking something where they can easily push from, like a, if they are using like a Azure Event Hub, we have a native integration from Event Hub to the Data Explorer. So it's just like a, they need to extend another consumer for their Event Hub, and they start pushing all these events also to Data Explorer to just add or bring some use cases on top of that. And what are those use cases? Usually like it's event tracing, and that's come into the domain of like where you want to track the lineage of the message from end to end, like how the message move through the different microservices, either it's being enriched or either a specific new message has been added for from one service to other. So through a common identifier, they are able to track like from end to end the message lifecycle. And then the other thing is like, because with Event Hub, you can also bring the some metadata, and this metadata is mainly about like each event, how much time was queued, sequence number, offset, and the partition. You can even do the debugging and understand like, okay, which service are taking more time and which is actually a bottleneck for your whole process. So this type of the things, because of this metadata and actual event moving from the one topic to another that is being enriched or something like you can track all those through event tracing, right? Another thing we see on top of that, there's another use case on top of that is like event store. So because you're also getting all the payloads from these messages that's moving from one place to another. So this event store provides you the whole history. So you can perform some stateful processing here, because when the events are moving from one to another, doing sometime like a stateful processing is not easy if you even use like some event processing engine like a Stream Analytics or something, Spark on top of that. So when the event is actually started from like a week ago, and now it's into the different state. If you want to do the stateful processes for such event, it's make the whole things complex. So for that type of the things, event store help you to do more stateful processing. So if you think about this type of the requirements are, this is another way to bring the Data Explorer into your infrastructure or into your analytics capability. And the third one is more about exploration, where you can even see the performance of overall your system to identify the back pressure and something like, okay, to see how the latency is working from end to end. Those type of things you can easily figure out from the through the Event Hub, and these are the some use cases that we have seen it. And I just want to show quickly another thing, like it's similar to this one, but it's a connected asset architecture where physical assets need to communicate to the cloud through some intelligent application, and then they also have some end consumer application that are interacting with these assets. This is a common to every industry, like either it's a automotive, energy, utilities, or something manufacturing. Every communication is happening through event, right? And then these events also to track device to cloud or cloud to device, their whole life cycle. These use cases and using positioning Data Explorer, considering Data Explorer has a event store, really helps to track your event life cycle, using event store even to get the more history and do more analysis on top of that. And the exploration stuff that I just mentioned for the other use cases, for the more classical microservices things, that's also going to work it, right? But this is just, you can imagine it's a lot simpler that I want to show here. But when we talk about the intelligent application, it can bring a lot of complexity, because you have more machine learning stuff here. Sometimes it's a simple data enrichment happening, but sometimes you need to take action on the basis of the events you are getting from the assets, and then you want to identify either the event or the message is delivered to the asset at the right time or not. So this type of the critical workload and the use cases that we are seeing is like customers are implementing, and this is another another use case or another like a data intensive application where you can look the Data Explorer has an event store and build this type of the application or the use cases on top of that. I don't know how much time I have more, but quickly I have the one last slide, like when that I want to cover is like why EDX is the best event store, because we just started talking about like, okay, how you can utilize it, but if we just look the few things, all these events are at the end a time series data, right? And EDX has like built-in time series capabilities, some advanced capabilities here. Either it's just like a simple functions, but at the end it's have capabilities to do some machine learning stuff also built in there. It's also optimized for storing this type of the data, because the moment you start you start adding observability components, you want to get it and push the data very fast. And with this capability to have manage ingestions type of stuff, it makes even more ideal for it to bring this data, because you don't need to manage another set of the tools or integration stuff to add observability to your system. And it also have a lot of open source integration stuff, for example, with like open telemetry and telegraph, where you can also push the this type of the events or telemetry to the data explorer without any external pipeline for that. It's also good because it's a purpose built it, right? It's gives you a lot of space efficiency when you are storing this huge amount of the data, because these events are growing at enormous scale. So in a short time, you are going to have like a terabyte of the data, but with its capability to store it in an efficient way, you have really really efficient way to store your data. And it also provides you like a data tiering part, where you can only keep the recent data into your hot storage, and automatically you can push the other data into the cold storage, and it works in a seamless way. You don't need to take care of this type of things, and you can also have a efficient way to control your cost. And this time series data and the telemetry data and all those events are really important, where you sometimes need to even share with other business units. So that's it's in-place data sharing is another good point to consider this as event store. And at the end, it's like a highly indexed store, so you don't need to think about its performance, either like the amount of the data or amount of the applications or the products you are going to onboard. It's going to work in the same way because of its capability to index everything, give you the performance that you are expecting from this type of the platform or observability solution that quickly responds to your recent events.